So today's problem of the day says, what is the acceleration of an object that starts from rest and travels 35 meters in 16 seconds? All right, so we're looking for the acceleration of an object that starts from rest and travels 35 meters in 16 seconds. So what do we have as given information in this problem today?
The initial velocity,
Yeah, what's the initial velocity?
0.
Yeah, because we start at rest, right? So Vxi is 0. Good. Anybody else? What do we have for givens?
We got the distance,
Yeah, what's the distance?
35 meters.
Yeah, 35 meters, right? That's how far he goes. Whoops, it's delta x. Good. And there's one more given information, right?
Time.
The time. Good. Yeah, Angel. What's the time going to be?
16 seconds.
Right. 16 seconds. How long it takes. And then finally, so we have our three pieces of given information. Next thing is to figure out the unknown. What quantity are they asking for?
Acceleration.
Acceleration, right. So I'll put that down. AX is my unknown. Good. So next step is to pick an equation to use, right? Which equation do I want to pick here if I have my initial velocity, delta x, delta t, and acceleration?
The third one.
Yeah, the third one, right? The third one has those quantities in it. Delta x equals Vxi times delta t plus 1/2 AX times delta t squared. Right. Okay, so we need to rearrange this, right? We need to get the acceleration all by itself on one side. And it's going to be a little bit easier to rearrange this if we remember or if we notice that the initial velocity is 0, right? Because if Vxi is 0, then Vxi times the time, whatever the time is, that's going to be 0 as well. So that whole first piece is 0. So we can rewrite it without that, and then it'll be a little bit easier to rearrange for delta x. Okay. Okay with that? So what should I do next then if I want the acceleration?
We can divide the time squared in 1.5.
Yeah, exactly. We can divide by the time squared and by the 1/2, right? Because both of those are being multiplied by acceleration, so that'll get acceleration by itself. So on this side as well, I also have to divide by the time squared and by the 1/2, but instead of dividing by 1/2, I'll multiply by 2. Same thing. So if I rewrite my equation now, after I rearrange it, I should have acceleration equals 2 times displacement divided by time squared. All right, now I can go ahead and plug my numbers in. That's 2 times 35 meters divided by 16 seconds squared. So on the calculator, 2 times 35 over 16 squared, I get 0.273. So a small acceleration. 0.273. And my units, I have meters and then seconds squared in the bottom, so meters per second squared. That works out. That's the unit for acceleration. And it's a small acceleration, but you can see the object starts at rest and it takes 16 seconds and doesn't go very far. So a small acceleration sounds okay for that.